using very different principles of tectonics. What you can show you, they have tensile structures, they have grid, structural framing networks, shell structures, conic developable surfaces, etc. And it's quite intricate. If you go into detail, they're all quite different, yet they're harmonized. They operate in parallel, observe each other, and they follow a single paradigm. That's my paradigm of the city development. Okay, this is another one. If you do topology optimization, you get an enormous amount of variety, and there are different tools. There are one tools which you wrote, the solid, which maybe you can translate it into concrete, those which start with linear elements, and you can end up doing that, translating this into timber on steel. Different, even in this kind of optimization process, there are different packages and different sets of parameters. So there's an enormous variety. If you compare this to the traditional structural thinking, where you have 3 solutions, here you have 300 solutions, which are distinct, but they're all optimization. Because what's the point of getting it down to the last 5%, right? Because you have lots of other things to think about. Expression, the kind of spaces, the kind of materiality. So these are kind of projects we're doing with students all over London, and using this variety, using that. All of them have exoskeletons, atria, a lot of bridges. So this is something you can do if you come to work with me as a student. The whole city detailed to this level in 1 year. That's of course very long, because in the office we have to do this in 2 months. But that is a kind of but what's very important for us as a firm, so we have done shells and tensile structures, parametric urbanism, topology optimization, tectonism, various ways of advancing, always using university, using this kind of post-professional degree. Been teaching for 30 years at the AA, developing these themes. So before we did our first exoskeleton, we had 10 years of research at the school. Before we did our first shell and tensile, we had 10 years of research in Vienna and AA, etc., etc. The same happens now with the metaverse, happens with everything. This happens with okay, so environmental logic, we earlier on started. So when you do the aspects of sustainability, which is about passive systems, for instance, shading, which is expressed on the outside, this starts with massing and volume configuration, self-shading, etc. you exploit, but then it also sun exposure, and you can run a sun exposure map and script the geometry translation directly onto this. So you can translate degree of sun exposure into density of louvering. And of course there could be 100 different systems. And you can run them, and then you put another building in, self-shading, these things thin out. And when you look at the building, you know, there must be something here. And in an overcast day, you can see where southwest, east, north. So there's a lot of things. So this is a project we're doing. It's the central bank of Iraq on the Tigris. And here we try to combine the double constraint structure and shading, brise-soleil, in these vertical elements. There's a big atrium in front, so you move up, you can see the city, and you interconnect these in levels. But what is beautiful is that it ties up, there's a gold wall in the bottom, and then you have the offices, and then there is a podium where the atrium, the light and path connects up with the atrium. So it's also this kind of articulation of a path. Wayfind, you can see how this looks very different from different sites. So it becomes like a sundial, or let's say, and is also in the Middle East very hot, that you can cut out the heat. But it also is, so there is no justification to have a tower symmetrical all around. It's irrational, but it's a wrong before. We have said wrong, it's taboo. We still do it sometimes, I'm sorry to say. You know, but it shouldn't. It should be taboo. Some people decide to put louvers on their facades. How are they going to do it? They wrap it all on sides. It's insane. Instead, it needs to be optimized and differentiated. So this is another one of our flagship environmental engineering. And what I like about it gives character, identity to the place, to the project. You sense it's in that climate, in that region. This is a research center in Riyadh. So it's very heavily on small windows, deep cut facades, but it still wants to catch a lot of light from where the sun is not hitting into it, and it wants to catch wind. And so we did the volumes and the shading canopies and the related geometry. It's all based on hexagon, but not repeated hexagon which squeezes and pulls. And the hexagon has 6 sides to connect instead of 4, so it's more communicative and connective. And you can see here, this is where you don't get so much direct sunlight, but you get the wind coming in. And what is beautiful about this, you have the solid part and the tensile part that follow the same environmental parameters. They orient their oculi in the same way, so you get system resonances, correlation. That's the beauty of it. And then you have outdoor courtyards, you have indoor atriums, and you have these very different situations. They're different and similar. Why are they similar? Because they're driven by the same parameter logics. And if you now make many more different buildings, they're all heavily articulate these, let's say, environmental logics. It's a unifying force, which we don't actually do so in reality, because the discipline remains extremely unsophisticated. You know, it's as if you wanted to write a typewriter with your fists. Your tools are crude. Your tools, however, are so crude that you can only do very primitive things, which, you know, you wouldn't, it's like, you know, the surgeon coming in with you and cutting you up with a ruler and so. I think there's something which becomes intuitive appealing to people. It's very loved and used for public events. It's 21st century, unmistakably, it's original, it's new, it's fresh, and it's still Arabic. It's still embedded in the tradition. You know, certain typologies, the quartet topologies, and the environmental kind of affiliation, etc. So I'm just racing through this. In the modernists got this right. This was before air conditioning. You had much more expressive. After air conditioning, what you get, mirror glass boxes spreading around the world. This is what we see. We've done that. It's how we look at this and how we do our translations of this. This is Brasilia. We now do this, of course, in a way which is varied. In the south, you have emphasizing the horizontal louvers. They can thin out to the north, and then they become extruded in the west. They become vertical because the sun is very flat. So you get this kind of transformation of the different sides. And you sense it on the inside. You know where you are. This is a building just finished in Prague. This is learning from, these are our projects where we're learning to work heavily with deep relief, with various types of resoleilling. There's multiple levels. There's the main ribs, there's the secondary, and then there's a grill, which is also complete directional. So in some spaces, when you to the north, you can look out and see the sky, but there's never a direct light coming in through the daylight kind of way. This is a proposal we did for Budapest, Rob, with this kind of shading, densification, and degrees of extrusion. Then also formal affiliations, that you're framing a surface with a backdrop, so you can make formally similar, because you have many ways of doing louvers, many ways of doing lights. So they could also share and participate in generating a space. So it's not pure engineering, it's engineering as a constraint, driving and then composing a space. There's a big difference. You know, engineering is our input. We are orchestrating engineering options into a composition. The more exposed facade becomes to the exterior, and then it shadows out to the interior, but this also tells you public-private. So there's information. You can use these details to characterize spaces. Go. This is a simple idea of system differentiation, never repeat, but self-similar and parametric variability within a parametric element, parametric components. This is the default. If you do a system, which parameters do you give it? Which variability do you give it? What is it driving? What is relating to? And so the default is never repetition. It's always variation. It's very rarely that repetition is the optimal solution. Particularly if you have a curved building. For sun exposure, it gradually changes as it decreases. Undercut is different from exposure, etc. These are very old projects. We've built this. And you can express larger open spaces to the exterior. So there's legibility to the exterior as well. And integrating podium and tower potentially. Tensor elements. There's many variations, studies, and options of this. So, shell structures, super high performance concrete, mushroom shells, and clear foil as a facade. You open it with a zipper. It's a house I was designing for myself in China, but never happened. Timber, roof overhangs as well, climatic, tropical climates. You can also affiliate to traditional tectonics of the region. So some of the Middle Eastern projects look Middle Eastern, climatic, but also typology, morphology, region materials. Some of the Chinese project, again, kind of 21st century China character was asked, how about this? There's something you can learn from those regions, features. But also, not only that you have relief and depth, this is just light and shadow studies, how a building, the character facade could be very different at different times of the day. It's the same building. All this, which I'm talking about, observer dependence, parameters based on the observer positions. So if you can also do this when you want to, from different perspective, it appears differently. This is look at what happens. It's only cameras changing. It shifts from a grid to a circle packing. It's the same architecture, depending where you look at it. You can affiliate, you can make something homogeneous or differentiated. Affiliate that sent to something else on the other side. So it looks either wave, circle packing, grid, depending on point of view. But this is the opposite. It seems to talk to you as circles, but then circles disappear into a grid, into a wave. So that's another topic. I'm not going too deep into this, but those are called phenomenology. So investigating the morphology with respect to perspectival positions. Also some kind of effects like this. The entrance is here, where we accumulate depths in the facade. This is student work, so again, this is a team in 1 year, they can generate use balconies as shading and or louvers, etc. Including the self-shading is integrated. And you can see the shift also from horizontal to vertical like was discussed. Another team. Shallow to deep depending on site. Sun exposure translated into geometry. So you get kind of these kind of visions for dense urban cluster. Okay. Fabrication. Done a lot of recent, I'm not sure how you do it here, but the last 15 years there's also been a lot of investment in studios, student studios, master studios in particular, the Martin, for instance, was at DLL, about experimenting with fabrication, pushing the industry, like pushing the engineers as well, the tool making, as well in building extruders, hot wire cutting, also the robotic fabrication technologies. And in Stuttgart they're doing a lot, carbon fiber weaving and threading, and you get these wonderful different experimental structures. You use inflation and then robotic carbon fiber laying cells. This is wonderful stuff. This is not only us. This is also connected to ex-students, etc. Aggregation of elements, minimal surfaces, but fabricating with kind of aggregating small elements, super thin elements. This is our own material, super thin shell, robotically folded. So this curved folding, the robot creases and then folds these elements, which then aggregate into a super thin millimeter aluminum shell. We showed it in the Venice Biennale. And then everything becomes part of an ornament as well. So we don't mind the bolting and they also enhance the kind of richness of the surface. 3D printing, we have an exhibition at our gallery where we also hosting lots of young talent and experimental work in tensile structures, hot wire cutting. So if you do these molds with milling the polystyrene versus hot wire cutting, it's about kind of 30 times faster with hot wire cutting. But then you have to live with these geometries, but they're actually quite lovely. So they're all kinds of ruled surfaces. And there are others studying this, kind of digital tectonics, 3D printed tectonics, etc., etc. So the enhanced tectonism for me is that it's not only technical. I'm emphasizing the communication aspect. You can see and learn what's happening, the natural differentiation of the structure. You look out that it's conspicuous enough. You look out for legibility. You look out for orchestrating the different systems to have both similarity and contrast, where you want